Hello everyone, welcome to the video walkthrough of our newly launched Global Load Balancer beta on DigitalOcean. Global Load Balancer increases your application resiliency by being able to load balance incoming HTTP traffic between servers located in different data centers. It allows you to dynamically failover the traffic in case of application failures in a data center and provides the ability to configure traffic prioritization. It also offers edge caching with default DDoS protection. The scope of this beta release is to connect droplets to Global Load Balancer. For GA, we will launch the support for other products like regional load balancers, managed Kubernetes, etc. to be able to connect to the Global Load Balancer. Today, you will witness how to create a Global Load Balancer from the DigitalOcean Cloud Console. There are two prerequisites to create a Global Load Balancer. You should have a valid domain that you will be connecting to the Global Load Balancer, and you should have a functional droplets in different data center that will be connecting to the Global Load Balancer. Now, since I have done these two steps, I'm going to jump into creation experience. In the DigitalOcean console, click Networking, go to the Load Balancer section, and click Create a Regional or Global Load Balancer button. Once you click Create, you can see you can choose Global as your load balancer type. As you can see, you won't see the option to pick a data center as you see in the regional load balancer creation. This is because as it is global, it gets available in all the data centers immediately. Remember that you need a valid domain to connect to the Global Load Balancer. You can connect the domain after creating the Global Load Balancer. You can enable the CDN caching. This will allow you to store your static assets in the edge POPs closer to the end user. Then you can connect droplets. Since I have created two droplets, one in SID1 and one in SFO3, I'm going to connect both of them to my Global Load Balancer. My application hosted in these two droplets are listening on port 5001. Hence, you can see the rule forwarding is set to that port. You can enable sticky sessions, configure additional health check settings, enable SSL redirect and idle timeout in the advanced settings. I will have to fix the health check port to 5001 as my application is listening on that port. Once those settings are done, you can select the project and click Create. Once you click Create, you can see the key onboarding steps listed. You can see the droplets are connected and showing up with the status collecting. This status will change to active once it passes the health check. Meanwhile, you can go to the settings or click Continue to connect the domain. Since I have already added the domain, I'm going to select from the drop-down. You can generate a new SSL certificate or use the existing one. Since I don't have an existing certificate, I will let it generate a new one and click Connect Domain. You can see the domain validation process getting triggered. Once the validation is complete, you should see the status of the domain change to active under Settings. It might take a couple of minutes for this to turn as active. As you can see, the status of the domain has turned active. Once the droplets status also becomes active, we are good to go. Now you can see under the settings, click the domain name, which points to a web page being served from the data center SFO3. This is because my HTTP request is from Denver, and the global load balancer by default routes the request to the origin server that is closest geographical proximity to the end user. Once the domain validation is done, once the domain status becomes active and the droplet status becomes active, you can test the URL by clicking this domain name here. You can see the HTTP request is being served from the data center SFO3. This is because the request is served. This is because I'm in Denver and the request flowing from Denver is routed to the origin server that is closest to the geographical proximity of the end user in order to serve the request. You can also change this default behavior and route the request to a specific data center by changing the traffic distribution priority in the settings. I'm going to test this by setting the priority 1 to be SID1 data center and setting the priority 2 to be SFO3. Now, if I go back to the web page and refresh it, it should be routed to Sydney. We can also test the failover scenario. I will hop onto the SID1 data center droplet and I'm going to stop the application. Once I stop the application, the traffic should be ideally rerouting the request to SFO3. There you go. That's it for the demo. To summarize, in this demo, we saw how a global load balancer can help you distribute incoming traffic between servers located in different data centers by routing to the origin servers based on the geographical proximity of the end users. It also allows to dynamically failover the traffic to a healthy data center in case of application failures in a data center. And finally, it allows you to configure DC priority by setting the traffic distribution priority for your data centers. In the future, we will add more features like customizable WAF, ability to add weights to the traffic distribution priority, and bot protection, etc. Thanks for watching the video. To learn more, please check out the blog link in the description of the video. Thanks again. Happy coding.